Alright, so here we are with our chapter 2, day 3, and then we're actually in a part 2. What happened in part 1 was that we were looking at factoring a trinomial, in fact, with a leading coefficient that was 1, and so now we're going for things that are other than 1. So this process does get a little bit more tricky, I guess, but you have two methods that you can pick from to use. So what I've worked through here on this assignment is some examples of factoring the same trinomial here. Notice that the leading coefficient is definitely not 1, it's 12. And then working through each way of doing that. So again, all of the examples that are down here are on something other than 1 as the leading coefficient here. So, taking a look at what our process is, when it comes to using the box, okay, this is actually a method that I usually present, but then recently found are using grouping, just like we did in our previous lesson. So, if we want to use the box to figure out how to do our area, the area model or the box to figure out how to do our factoring, the idea is that you would take each of these pieces, so this one here of 12x squared, and you put that here. We also take this last piece, which is negative 6, and put it here, because we know that this trinomial is what's supposed to result from this 2 by 2 box. So then, once we know that those are the key pieces, notice that I'm taking 12 from that leading coefficient and negative 6 from that constant, and we're going to multiply them. So when you multiply them, you get negative 72, and that, working backwards, is what we are trying to find the multiples of in order to find out what would add to be this guy in between, which is negative 1. So if I take the time to list all of the factors of negative 72, which I have here, there's only one of them that will end up adding to be negative 1. So that's 8 and negative 9, so over here. Alright, so 8 and negative 9 are going to end up being our values that are in here. So notice 8 is there and negative 9 is there. So now we have completely filled in the box, and so now we need to undo that. So in order to get to the box, we multiplied the two pieces that are on the ends. So in order to get outside of the box, we're going to basically do a GCF. So we're now going to do a GCF of every single row and every column. So taking a look at this box, for instance, how do we get negative 3? Well, what is the largest thing that can divide into negative 9x and negative 6? And so that is negative 3, and so we kind of take it outside here. Then if we look at this first column, the number that's alike between 12 and 8, the largest one is going to be 4, and so that's where it comes from. And then also looking at what we have here from our x's, the lowest power is 1, and so that's why I'm taking it out here. So again, all you're doing is taking every single row and column and pulling out the greatest common factor. So as we look at the next piece, 8 and negative 6 has a 2, and then 3 from 12 and 9, and an x of a power of 1 comes out front. So ultimately what our answer is going to be are these pieces that are outside on these sides. And so notice 4x minus 3 ends up being one of our factors, and then 3x minus 2 is one of our factors. The other way that you can do this is by factoring with grouping, okay? And so factoring with grouping allows you to do pretty much the same process, of course, because we're getting the same answer, but we do end up taking the leading coefficient, which is 12, and the constant, which is negative 6, as we did over here, and multiply that to get negative 72. Then we need two factors of negative 72 that add to be negative 1, so we're doing this process again here. But then what we end up doing, instead of filling in the box and finding GCFs of our rows and columns, we actually end up, instead of writing them in the box, writing them in a line here. So here's where our 8x and our negative 9 are, because technically negative 1x is the same as 8x minus 9x. So if we go ahead and put them into the formula, replacing this negative x with these two pieces, now we have a 4-term polynomial that we can use grouping with. So, as we did in our last lesson, factoring by grouping, you're going to go ahead and group the first two and the second two, take out the GCF, notice that what's in parentheses is alike, take that alike piece out, and then you have your leftovers. So you can see that we get the same answer both times, but one of them uses this box of rows and columns, and one of them uses grouping. I have started to like grouping a bit more than the box, but since I've kind of been doing the box for a while, I do use that one, or tend to use that one more often. So I'm going to go ahead and do these two examples here, and I'm going to use both of the techniques. So taking a look at this first one here, I may as well go ahead and use the box for this one, and then I'm going to try using grouping for this one. If you want to pause the video and try starting out doing either of them, that would be a good idea, so you can see if you can get there just like I will. So, taking a look at this first one, again we're using the box, but we have to do the same process to start with either of the techniques anyway. So we're going to take this first piece, which is 2, and the last piece, which is 3, and multiply them in order to get 6, which is the piece that we are going to find all the factors for. Once we find all the factors, we're going to find the set that adds to B7. So let's take all the sets of 6, 1 and 6, which honestly I could stop now because that's 7, but let's go ahead and list them. We have 2 and 3 as well, and then -1 and -6, and then also -2 and -3. So going through the sets, again, the first one I listed ended up being the one that adds to 7 anyway. So the next thing we do is fill in with these 1 and 6, we fill in the middle of the box. So I'm going to have to scroll down a little bit. So inside the box is going to be our 2x squared, which we started with from the problem. The 3 here that we started with from the problem, but then instead of making a 7x in this diagonal, we're going to put a 1 and a 6 from the fact that those are the ones that add to be 7. I'm also going to put an x next to them, because those are the pieces that are replacing the 7x, not necessarily just the 7. So then we go ahead and find the GCF of each of the rows and columns. So if I take a look at this second column, 6x and 3, the only thing that's alike that will divide evenly into both is a 3. After that, if I take this first column, 2x squared and 1x, there's at least an x in both of those. Then I go along, for instance, the top row, 2x squared and 6x, there's at least a 2 and an x in both of those that can divide out evenly. And then the last one is a little sad because it turns out it's only a 1. So that means that our two factors that are actually going to equal this original trinomial is going to be x plus 3 and 2x plus 1. Alright, the next process that we are going to try is our grouping, but again it's the same process to begin with, so we're still going to take this leading coefficient and this constant and multiply them. So 3 times 8 is what we're looking for, but then technically the factors that make 24. And again we want the ones that add to 10. So if we start listing all the factors that multiply to be 24, you've got 1 and 24 of course, 2 and 12, 3 and 8, and 4 and 6. I could do all the negative pieces, but I do notice that this is trying to be a positive 10, so really we can just stop with 4 and 6. We don't need to be redundant. Alright, so then we're going to go ahead and rewrite the original trinomial, so 3x squared and then plus 8, but in the middle we'll have a 4x and a 6x. So going ahead and grouping those, we have these two that will group, and then these two that will group, and then we can find the GCF of each of them. So looking at this first piece, we have a 3x squared and a 4x. 3 and 4 don't have any alike pieces except the number 1, and then the lowest power is going to be just an x to the power of 1. So an x will come out front, and we'll be left with the result of 3 and x from this first fraction, and then a 4 from the second fraction. Then the next one, we're going to go ahead and try to divide out something from 6x and 8. Since both of them don't have any variables, one of them has a variable, but they both don't. We can't take out that, but we can take out the fact that they're both even, so we can at least take out a 2, which leaves us with 6x in half was 3x, and 8x in half is 4. Whoops. Alright, so if we take out the blue piece, which notice they are the same, we're going to get 3x plus 4. And then our second terminology piece is x plus 2. Alright, so that is our trinomial using the grouping method, and then, factoring the trinomial with grouping, and then the first one here was factoring using the box. But either technique ends up doing the same thing. They end up getting the two factors that would have made that trinomial. So, if you would like to, there are a few more examples down here, but I'll probably move them to the assignment so that you can do them there instead.